Hi all, welcome back to software engineering course. Let's get started. So we will get started by the topic psychology of testing. Now this topic it says what should be the psychology of the person who is testing the software. Okay, so we had already seen that in testing the software under test is executed with a set of test cases. Now these test cases it contains the steps that are required or those steps which will be performed on the software so that you can find out whether that step or the function is working right or wrong, whether what is expected is actually getting or you are getting the expected equal to actual output. Okay, but there is no formal or precise method for selecting your test cases. There might be n number of rules or restrictions for deciding the test cases, but selecting the test case is still a creative activity and that relies on the genuinity of the tester. So because of this, the psychology of the person who is performing the testing it becomes very important. The basic purpose of the testing is to detect the errors that may be present in the program or the software which is under test. So the intent of the tester or the person who is doing the testing it should be like the program or the software it does not work. Your intent it should not be like that the program works. If you think in that direction that whatever is given to you it works, if you are in that intention, so what will happen is like you will write the test cases so to pass the program or to pass the steps in the test cases. But if you think or if your intention is like the program does not work, so that thing will be in your subconscious mind, and what you do is like you will try to select the best test cases that will destroy the software. So destroying the software means you will find defects in the software. Okay, so we call the testing process as destructive process, where the tester, that is who is testing the software, he has to treat the program as an adversary that must be beaten by the tester by showing the presence of errors. So this is one of the reasons why many organizations they employ independent testing teams. So that means your development team, code development team would be separate and the testing team would be separate. Why does why do the organization have two independent team is like if the developer who has developed the code, if he starts testing, he will always test the positive parts and he will not have the creative mind to detect the errors. But say suppose if there is separate testing team who has no knowledge of how the code has been written, so then what will happen is like they try to destroy the software. That means they try in many numbers or many ways to find out the errors in the system. Okay, so next we will study about levels of testing. To understand this one, first we will see the diagram of it. So in this diagram you can see different levels of testing. Those are your unit testing, integration testing, system testing and acceptance testing. Now these are the basic levels. Okay, so these different levels of testing they attempt to detect different types of faults or defects. Okay, now the relation between the faults it is introduced in different phases and this diagram it explains that. So during what phase, okay, these are the phases. So during what phase what type of errors or the faults could occur in the system. So the first level of testing it is called as unit testing. So again we had discussed this in the last chapter, right, in the coding part. So this unit testing again it is a verification of the code developed by the individual programmers. So unit testing comes into picture when you have code. Okay, so again this unit testing would be done by the developer himself. The one who has written the program, he will test his own program. Okay, now this is a generally a module is offered by a programmer for the integration and used by the others only after it has been unit tested satisfactorily. Okay, so the developer what he has to do, he has to write a module or code for a function. So he has to test it thoroughly and if he thinks there are no defects in it, then he can give his module or code to others so that integration can be done. So the next level here is the integration testing. It is in this, many unit tested modules are combined into subsystems. Okay, so in unit testing, you will have these separate units, right? Separate units. So once you combine all these things, again after unit testing, they would be coming into integration testing. So you will collectively test these units. So the goal of the integration testing is here to see if the modules can be integrated or the modules are integrated properly or not, whether these units are these units or modules are integrated properly. So the emphasis on testing the interfaces between the modules. So this testing activity can be considered testing the design of the system. Integration testing, it means testing the design of the system. So the next level is acceptance testing. So here the entire software system is tested. The reference document for this testing is your requirements. This is SRS document. Okay. So the goal here is to see if the software, okay, the goal of your system testing is to check if the software meets its requirements. So this is usually a huge task to check the entire requirements whether they are captured or not. Okay. So this is essentially a validation exercise, and in some situation it can also be the validation activity. So the next one is the acceptance testing. So it is performed with the realistic data of the client to demonstrate that the software is working satisfactorily. This client, he does the acceptance testing. He checks to see whether the software it would actually meets the client needs. So it may be done in setting in which the software is to eventually function. So acceptance testing, it essentially tests if the system satisfactorily solves the problem for which it was commissioned. Now these levels of the testing are performed when a system is being built from the components that have been coded. Now we have another type of testing which is called as regression testing, and that is performed when some changes are made to the existing system. Some code changes. Okay. So we know that the changes are the fundamental to the software. That means in any stage it can your client can come and say that there is a requirement change or you have to enhance it, and so that the software must undergo some changes. So however, when modifications are made to your existing system, again you have to do a testing. So why testing has to be made when the modification is done? That is to again make sure that the modification which you have made now, it is not destroying or it is not breaking any of your existing features. So, besides ensuring that the desired behavior of the new service or the new requirement, you have to also test that the old services or the old code is maintained and it is working properly. Now, this is the task of regression testing. So, for regression testing, some test cases have been executed on the old system. They have to be maintained along with the output produced by the old system. Or whenever you have done a round of testing and say first level of testing is done, then some code changes were done, and then you have to do regression testing. That means the first testing whatever you have done, you have to contain or you have to retain the test cases and the output produced when you have done the testing. So these test cases are executed again at the time of regression testing on your new or the modified system, and its new output is compared with the old output to make sure that the system is working as before on those particular test cases. So thus frequently it is a major task when modifications are to be made to the existing systems. So the complete regression testing, if you have a large software system, can take a reasonable amount of time even if the automation is used. So if a small change is made to the system, often the practical consideration it requires that the entire test suite is not to be executed, but regression testing be done only with the subset of the test cases. That means whenever you have large and complex system and you have, say suppose you have done a code change after the testing has been done, so you cannot even if you have the automation testing in process, you cannot have the entire regression or entire old testing, old functionalities can be tested. So you have to choose some important points or the functions, or you feel whether the code can break. So those things you have to do a round of testing in regression testing. Okay. So now we will look into the testing process. We know the basic goal of the software development process is to produce the software that has no errors. That means it does not contain bugs, or it contains a less number of bugs. So testing is a quality control activity which focuses on identifying the defects. Just not identifying the defect, but those defects have to be later removed. So we have again seen different levels of testing which is needed to detect the defects injected during the various tasks in the project. Like for in the SRS also there might be defects, then design also there might be defects, coding however it would be there. So the testing has to be done properly in a project. The testing process of a project, it consists of three level tasks, that is test planning, test case design and test case execution. Now we will understand what do we mean by test planning, test case design and test execution one by one. The first thing is a test plan. Okay. So in general, in a project, what happens is your testing process, it starts with a test plan. That means all the planning that is required for the testing phase would be present in your test plan, and it terminates with a successful execution of your acceptance testing that would be done by the clients. So a test plan, it is generally a document for the project that defines the scope, the approaches to be taken and the schedule of testing, as well as it identifies the test items for testing and the personal or the person who is responsible for the different activities in testing. In general, this is a test plan is a document which contains everything about your testing. Who will do what activity, when the testing phase has to be started, when it has to be completed, all these things. Okay. So test planning can be done it well before your actual testing starts. Okay. And it can be done in parallel with the coding and the designing activities. So for test plan, the inputs are your project plan, your requirements document, that is SRS, and your architecture or the design documents. So these three are the inputs for your testing plan. Now we will understand what the test plan should contain. What are the things it will contain? So basically it would contain five things, that is your test unit specifications, features to be tested, approach for testing, test deliverables, and the last one is schedule and task allocation. So these things, five things would be present in your test plan document. So, as we had seen earlier, the different levels of testing have to be performed in a project, right? These levels are specified in a test plan by identifying the test units of the project. A test unit is a set of one or more modules that form your software under test or the entire project. The identification of these test unit, it establishes the different levels of testing that should be performed in a project. Okay. So a number of test units are formed during the testing, starting from your low level modules to which have to be unit tested. That is the first module that have to be tested individually, and these are specified as test units. Then once you have done the low level modules, you go for the higher level units or the modules. Then the combination of those things. So these things we call them as the test unit test specification, the test or the modules. Okay. So the basic idea behind forming a test units is to make sure that the testing is being performed incrementally from low to high. Okay. So the next one is features to be tested. So this will include all the software features or the characteristics and combinations of different features that are to be tested. Software feature is a software characteristic which is specified by the requirements or the design documents. So again, this may include your functionality, performance, design constraints and attributes. The third one is approach for testing. So the approach for testing, it specifies the overall approach to be followed in your project. The techniques that will be used to judge the testing effort should also be specified. So again, this is sometimes it is called as testing criterion, or the criteria for evaluating the set of test cases used in testing. So in the previous sections we had discussed many criteria for evaluating and selecting of the test cases, right? The next one is test deliverables. So these test deliverables, it should be specified in the test plan before your actual testing begins. These deliverables could be a list of test cases that you have used, or it can also be the test results or the list of defects, summary report, data about your code coverage, all these things. The last one is schedule and task allocation. So your test plan, it contains or it specifies the schedule and effort to be spent in the different activities of the testing and the tools used for it. The schedule, it should be consistent with the overall project schedule. The detailed plan may list all your testing tasks and allocate them to the test resources who are responsible for performing them. Basically, it is nothing but this test plan, it should contain the schedule or the time required to complete your testing activity, and when what activity has to be done, and the task allocation, it is nothing but who will perform what task, who will perform what testing. Okay. Next thing what we discuss is test case designing, right? So the test plan, it focuses on how the testing for the project will proceed, which units will be tested, and what approaches or the tools are to be used during the various stages of testing. But it does not deal with the details of testing a unit, or it does specify which test cases to be used. So your test case design has to be done separately for each unit. Based on the approach specified in the test plan, the features to be tested and the test cases are designed and specified for testing the unit. So your test case design, or the test cases, it is a document. So it would look something like this. You have the requirement number. What is the condition to be tested? Do you have any test data and the settings for that particular requirement? And what is the expected output? So you have to maintain a document something like this. Okay. So sometimes this test case specification document, right? It is also used to record the results of testing, like whether the step has passed, failed, or whatever the defect has come or not. These all things. The evaluation of the quality of the test cases, it is done through test case review. The test case specification document, it is reviewed using a formal review process. That means whenever you write a test case, it is not the final one. Your leaders or the managers, what they do is like they verify whether whatever you have done or whatever you have written in the test case is actually correct. That review will be done by your leaders or the leaders or your managers of the testing team. So another reason for specifying the test case in a document is the tester can select a good a good set of test cases for testing. So these specifications can be used as scripts during regression testing. So this document what you can see here, it is basically a test case design document, or basically a test case. Okay, so it will contain these all things like the requirement number, condition, expected output, and when you actually execute this test script or the test case on the software, you will have the actual output as well. Then you compare this expected output, this one, with your actual output, whether both are correct or not. So now this is a document which you will use for regression in future whenever there is any code changes. Okay. The next one is test case execution. Okay, now you have done your test case designing is done, schedule is done, everything is done, and say suppose your the code is ready. The next step is the execution of the test case on your project. Okay, so with the specification of the test cases, now the next step is to execute them. So this is not a straightforward task. Test execution is not a straightforward task. The test case specification, it specifies only a set of test case for the unit to be tested. But executing the test cases, it may require the construction of the driver modules or the stubs. So we already know what do you mean by driver and stubs. Okay. So it may also require that the modules to be set up the environment as stated in the test plan. So whenever you have the project ready, it doesn't mean you can directly start it. So you have to set up the environment if necessary. Okay. So whenever you execute the test case, you find various outputs. Again, these outputs are the result of your test case execution. The most common output are the test summary report, whether the expected result is same as your actual report, and the error report or the defect report. Now these outputs, or these deliverables, these are needed to check if the testing has been done satisfactorily, whether there are any critical defects or not, whether we can give this software to the client or not. We can decide based on these deliverables. Now this summary report, it gives the total number of the test cases executed, the number and the nature of errors found, and the summary of the matrix collected data collected. The error report is the details of the errors found during testing. Again, this error report, it should contain the priority of the defect and the steps to reproduce the defect. We will study this in the next topic. Okay. The few metrics like testing effort and computer time are also useful for monitoring the testing. So in this test case execution, it is basically nothing but you execute, or you execute the test case on the system. Like in parallel, you see the test case what you have written and apply the same test case on the software to check whether you are getting the expected output or not. Okay. So the last topic in this is the life cycle of a defect. So as we all know that the defects can be found at any stage, but here we talk about the defects which are found in the coding. Okay. So whenever you find a defect, what you have to do is like you have to log the defect in a defect control system. That means there would be some tool for the defect management. You have to open that tool, you have to select your project, and you have to submit the defect. Okay, so you cannot directly call up the developer and tell him like the defect, so this is the defect, please fix. No, you cannot tell him like that. So for reporting purpose, you have to log the defect in the defect control system or any other tool. Along with that, you should have sufficient information like in which screen you found out the defect, what is the steps that you performed so that your defect came up, the screenshot of the defect, and user. If suppose you have different accesses, you can specify for which user that defect came up. So here is the defect life cycle. Okay, so first what you do whenever you enter a defect, or you raise a defect in a defect control system or a tool, first it would be in the submitted state. Okay, now once it is submitted, again the developer who is responsible for, who has developed that code, and for that code you have raised a defect, so that developer, he will fix the defect. That is, the next step is to fix the defect by the owner, that is by the developer. Now once your developer, he fixes the defects, then what he does, he changes the state of the defect from submitted to fixed. Okay, when you submit the defect first time as a tester, it would be in a the defect would be in submitted status. Then the developer would fix the defect, and then he moves the defect status to fixed. Now once it is fixed, it is not like the process is done here. So whoever has raised this defect, that is the tester, he has to recheck whether the defect is still existing. So once, say suppose, the tester who has rechecked the defect and he find out that like the defect is not present anymore, he can close the defect. If suppose he finds that the tester finds that whatever the fix the developer has given, suppose it is failing, that means the defect is still present, then you can reopen the defect. Okay, so this is a defect life cycle. Okay, now let's have a quiz. So here is your question, that is, what are the inputs for test plan document? You have got a minute of time to respond to this one. Okay, time up. So this completes your fifth chapter. Okay.